Last section of chapter 8. Okay, we already went over this a little bit yesterday, so we're just going to review all of the theorems, and then we're going to do some examples. So the first one is the side splitter theorem, okay, theorem 65. And basically what it says in a nutshell is when you have, okay, a line, in this case it'd be BE, that is parallel to one of the sides of a triangle, which in this case is CD, and it intersects the other two sides of the triangle, okay? The triangle is now cut into 4 pieces, and these pieces are proportional. Now, what would the proportion be? Well, if given BE is parallel to CD, you're going to have that AB, which we will call X, to BC, which we will call Y, will equal AE, which we call NX, to ED, which is NY. Okay? So that is the proportionality that we're talking about. Now, I want you to understand the difference between side splitter and trying to prove triangle similarity here. When we're talking about side splitter, we're talking about the fact that AC and AD were split up or cut in such a fashion that the individual pieces of those two sides are proportional. Does that make sense? Now, as far as if we were trying to prove triangle similarity, it'd be something like this. Okay. If I want triangle similarity here in this case, and I wanted to prove that ABE was, I tell you that ABE is similar to ACD. Now in this case, you would say AB small triangle to AC large triangle side equals AE small triangle piece to AD large triangle piece. That is for proving similarity. Okay? You go small triangle to large triangle. That is not the case for side splitter. But I wanted you guys to see the difference because that is confusing sometimes. Well, what is it? Is it the big triangle to the small triangle? Is it what's going on here? Are we trying to prove similarity? What are we proving? So in side splitter, we're proving that the individual pieces are proportional. Does that make sense, gentlemen? Okay, thank you. Yes, sir. Okay, I have a question now that has nothing to do with this, but okay.
Like what happens if it says the given is like triangle A, let's just say is similar.
There is no such thing as triangle A, but okay, triangle ABC, okay.
Yes, congruent to triangle or
Congruency is not what we're doing. Okay, it's similar to triangle DEF. Okay.
and then it says that triangle DEF is similar to GHI,
Okay.
and then it says to prove that triangle ABC is similar to triangle.
GHI, that would in that case be transitive.
So you just put triangle similarity transitive property.
No, you would just say transitive property in that case. If you're saying that triangle ABC is similar to DEF, and DEF is similar to GHI, then triangle ABC is similar to GHI because of transitive property. It's the same thing as saying A is congruent to B and B is congruent to C, so therefore A is congruent to C. You can use transitive property for segments, for angles, for triangles, for polygons, anything like that. Thank you. Yes, sir. Can I use a side splitter to prove similarity? Yes. If you have side splitter here, okay, and I know that x is proportional to nx and y is proportional to ny, okay, and I have some values in here. Now you can see if AB to AC, you could use this bottom part down here. Okay? If that holds true, then they're similar. Does that make sense, son? Thank you. Yes, sir? Okay. May I continue? Thank you. Okay. Now, Theorem 66. Very similar to side splitter, okay? And we're going to go ahead and help you guys out, and we're going to call it a reduced name. We're going to call this the 3 parallel transversal splitter. Is that fair?
Yes, sir.
Because we're talking about 3 parallel lines and it's splitting the transversals. So 3 parallel trans splitter. That will mean 3 parallel line transversal splitter. Okay? And basically what it says is if 3 or more parallel lines, which in this case would be AB, CD, and EF, okay, are intersected by 2 transversals, the parallel lines divide the transversals proportionally. It's almost exactly the same as side splitter. It's almost exactly the same, okay? So basically, if I'm given that AB is parallel to CD is parallel to EF, then I'm going to get that AC, which I'm going to call X, to CE, which I call Y, is going to equal, or it's going to be proportional to, sorry, X to Y is going to be proportional to BD, which is NX, to DF, which is NY, where N is a whole number, a decimal, or a fraction. If, for example, BD was larger than X, then maybe that'd be at a 3-to-1 ratio, so maybe that'd be X to 3X, and this would be Y to 3Y. Okay, but the N could be a whole number or a fraction or a decimal. If it's a whole number, we're having a dilation. It's increasing. And if it's a fraction, we're having a contraction. It's coming in. It's getting smaller. Yes, sir?
I thought that was for like the parallel lines.
You thought it was for what, sir?
If AF was the transversal, wouldn't AB
AF is not the transversal.
then why is it
AF is here so that you can prove why side splitters in existence. If you have AF here, I'm going to basically be cutting this into 2 different similar triangles. So once they're similar, that's how I get this proportionality. Okay? So the AF is just there to help prove why they're proportional in the first place. And we went over that yesterday. If you cut this here, and this is parallel to this, you're going to have this guy is congruent to this guy, remember? And then if you come this side here, this guy will be congruent to this guy, right? Making this guy similar to this guy because of angle, correct? But then these 2 angles are congruent to themselves, okay, because of vertical angles. And then you have, let's see, where's my second angle? Oh, okay. This guy has to be congruent to this guy because of the subtraction property. Okay? When you subtract the same congruent angles from 2 angles, then the differences are congruent.
So it's going to affect the lines of AB or...
No, this AF does not affect A, B, C, D, or EF. That's why it's in dash, my brother. That's just to help you understand how the heck did you get these similarities in the first place. Okay? Thank you, sir. May I continue, gentlemen?
Yes, sir.
All right, awesome. Now, last theorem. It says here that if a ray bisects an angle of a triangle, it divides the opposite side into segments that are proportional to the adjacent sides. Let me give you one little hint. AD is the ray, never the adjacent side. So when I'm given that AD is bisecting angle BAC, okay, I'm going to know that BD, which is X, is going to be, why is that in degrees? That should not be in degrees. I'll fix that in a second. To NX, and DC, which is Y, to AC. Now let me just get rid of this though, because that's just wrong. Okay, sorry about that. So again, when you have this ray bisecting an angle of a triangle, okay? The side that got split, the side that is opposite the angle that got bisected, that piece is going to be proportional to the adjacent side. And the other piece is going to be proportional to its adjacent side. The ray is never the adjacent side. Does that make sense, gentlemen? You got a question, Pablo? No? Okay. May I continue, gentlemen?
Yes.
All right. Let's do some examples now. Okay. So for problem 1 here, I'm given that BE is parallel to CD. And they tell you lengths as shown. So you have all the lengths here. You have AB, BC, BE, and AE. I have a hand up here. Yes, sir. Sure. We want to first solve for A, which is ED. Okay, son. How would I do that, my man? Okay, that's exactly right. He said he would do 4 to 2 must be equal to 7 over ED, we'll call it. Why? Well, this is side splitter. Since BE is parallel to CD, okay, it means that BE is parallel to one of the sides of a triangle. And it does intersect the other two sides of that triangle. So therefore, the pieces are going to be proportional. So 4 to 2 is going to equal 7 to ED. This is going to be 4 ED equals 14. So ED will equal 3.5. Does that make sense? Yes, sir. You're usually going to get pretty easy, simple decimals. If you have a situation where you have a decimal that just keeps going on forever, I would suggest rounding to the hundredths place, just to be safe. Okay, be a good estimation. Thank you, sir. All right, now, how would you find CD? Hint, hint. We're not using side splitter anymore. Yes, sir.
4 over 6.
Fantastic. It'd be 4 to 6. So I took this 4, small triangle, to the other side of the small triangle, equals 6 to CD. Fantastic, son. The 6 from AC, the large triangle, to the corresponding side of BE, which is CD, the large part of the other side of the large triangle. Do you guys see how that is different than side splitter? Okay, because here we're talking about similarity now. Okay, so again, I went 4 to 6, side of little triangle to side of little triangle, equals 6, which is all of AC, okay, side of large triangle, to CD, which is side of large triangle. And CD corresponds to BE. So now when we cross multiply, we're going to get that 4CD equals 36. So CD equals 9. Does that make sense, gentlemen? Promise? All right. May I continue? See a few people writing. Let me just give them a second. We're good? All right, thank you, gentlemen. Let us continue. Now, I've got given that A is parallel to B, which is parallel to C, which is parallel to D, and they tell you that KP, the whole entire side here, KP is 24. I want to find KM. How would we do this? Yes, sir.
5 over 15 x over 24.
Fantastic. I couldn't have done it better myself. Well done, son. Since we have here the 3-line transversal splitter, okay, doesn't that mean that FG corresponds to Km, and GH corresponds to MO, and HJ corresponds to OP. Correct? Right? And that FA, FJ would correspond to KP. So let's take the individual pieces of what we know, set them up to what we need to know. So I have FG, which is 5, to FJ, which is 15. Well, that must equal KM, which corresponds to 5, to 24, which corresponds to FJ. Go ahead and cross multiply here, gentlemen, and we are going to get Km equals 8. Km equals 8. How did I do that? Well, that's 5 times 24 equals 15 km. Now, what I did is instead of multiplying, I made my life easy. 5 goes into 5 one time, 5 goes into 15. 3 times 24 divided by 3 is 8. Yes, sir.
How come it be 24 on the left it says 5?
What, my man?
How's it 24 if on the left it says 5, 2, and 8?
Because they tell you that KP is 24 when you read the problem.
Oh, how can that be? Like on the left side it says 5, 2, and 8.
Who said that FJ is equal to KP? FJ is proportional to KP.
But if they're parallel,
Okay, look. This is parallel, this is parallel, this is parallel. This piece corresponds to this piece corresponds to that piece, this piece corresponds to that piece. So FJ corresponds to KP. Who cares if they're slanted or not, sir? I'm not trying to be rude.
you're talking about like it goes up and down.
No, when did I ever say it was up and down? No. I said the height, yeah, from K to P, yeah, that height is 24. Oh, yeah, but learn to read. Oh, my God, okay. This is going to make you happier? Look, we want to make everyone happy out there in computer land. How about this, son? Is that better? Are you happy now? Okay, now it makes sense. Now the world has just opened up. Okay, the world is your oyster. Okay. Does that make sense? Are you sure? Thank you, gentlemen. Hey, let us continue. Now, RVS is congruent to SVT. Okay. This is the other theorem we were talking about with the ray that's bisecting the angle. So, what would I do, my man?
Then
How would I find ST, sir?
go 8 over 4.
Okay. 8 to 4 equals 10 to x. Cross multiply. X will equal 5. Very good, sir. Why? Well, VS bisected angle V. So that means that, remember what the theorem states. Since it bisects angle V, the side opposite of the bisection is going to be proportional to its adjacent. This side of opposite of the angle that was bisected is proportional to its adjacent. The ray is never the adjacent. Yes, sir.
So that would mean that in this particular one, you wouldn't be able to go, like, if you didn't know x was 5, you wouldn't be able to go 4 to x.
You could have done 4 to x equals 8 to 10. Absolutely. Of course you could have done that.
Sorry, sir.
Okay, that's the bell. We'll be back to finish this up. Go. All right, so we are back now. We solved for ST by using the theorem that states that when the ray, okay, in this case VS, bisects an angle of a triangle, it is going to cut the opposite side of that triangle into proportionalities with its adjacent. So 8 to 4 is going to be equal to 10 to x, or 4 to x will be equal to 8 to 10, or you could do also 4 to 8 equals x to 10. Any of those combinations using the means extremes theorem We could switch them around, and we're still going to get the same answer. Does that make sense? All right, boys. Now we got a proof. Fun stuff. I love proofs. Gotta love proofs. All right. So we have this figure here, and in this figure, they tell us that XA is parallel to YZ. So that's going to be my first statement. XA is parallel to YZ, and that is given. Now I am trying to prove here, guys, that WX to XA is proportional to WY to AZ. So let's look at what they first give us. They tell us that XA is parallel to YZ. Well, isn't that side splitter right there? So since I have XA parallel to YZ, okay, and it's parallel to one of the sides of a triangle, and it intersects the other two sides of the triangle, then I can immediately state that WX to XY, remember we're not going small to large here, we're going piece to piece, is going to be congruent to WA to AZ, and that would be side splitter. Okay? Now I can use my next given. Angle XAY is congruent to angle XYA. Given. So I have XAY, which is this guy right here, is congruent to XYA. So it's congruent to this guy. Now, you can try to continue to see if you can find other angles to prove similarity and go a very long route, or you could try to realize that right here, I've got an isosceles triangle. So since I have an isosceles triangle there, and I know that angle XYA is congruent to angle XAY, can't I say that XY is congruent to XA, because if angles, then sides? Now that I know that XY is congruent to XA, look at step 2 here. Don't I know that XY is the same as XA? So can't I now prove that WX to XA equals WA to AZ, because I heard someone say it, because of substitution. Very good. And that is my proof. I substituted XY for XA, and that is what I'm trying to prove. Does that make sense, gentlemen? Okay? So again, if you didn't want to go this route, you would have had to have proven somehow that XWA was similar to WYZ. Then you could have WX to XA is equal to WA to AZ. But that's going to be a mission. So stick to what I had said before. Please. Does that make sense? Yes, no, maybe kind of, sort of?
Yes, sir.
All right. May I?
Yes, sir.
All right. Last but not least. Now this is a very, very good one. Okay? Very simple. First thing they tell you is that DH is parallel to BC, which is given. So let's investigate that fact. DH is parallel to HC. So isn't this side splitter? Look at this triangle right here.
Oh, yeah.
Isn't DH parallel to CB? Isn't that parallel to one side, but it intersects the other two sides? So isn't that side splitter? So I can say now DE to CD, or actually looking at what the proof wants, CD to DE will be equal to BH to HE. And that's going to be side splitter. Does that make sense, guys? Does everyone see how and why I split it up that way? Yes? Okay, now, let's look at the next fact that they give us. HF is parallel to BC, given. So let's investigate that fact. Since HF is parallel to BG, don't I have yet another side splitter? Because this HF is parallel to BG, HF intersects the two other sides. So we have side splitter again, correct? So wouldn't I have in this case BH, BH to HE equals GF to FE. Is everyone with me so far? And that'd be side splitter as well. What you guys have to see, very good, son, and it will be transitive at the end. Well done. What you have to realize, guys, is that this guy right here, BE is shared for both. So that's why I was able to set up a proportions with two of the same sides. So now that CD to DE equals BH to HE, and BH to HE equals GF to FE, it's kind of like what we were saying earlier in the lesson. That is transitive. So I know now that CD to DE will equal GF to FE because of transitive. Does that make sense? Are there any questions at all? Yes, sir.
I would make proportional to C.
Wait. What would make proportional to CB?
Like, why would it be CD over DE equals...
CD over DE equals.
No, what I'm asking is, why wouldn't it be...
Go ahead. Are you thinking why wouldn't it be CB? Why wouldn't CB and BG be involved? Because we're dealing with side splitter. We're not dealing with similar triangles. We're dealing with side splitter. When DH, okay, parallel to CB, what got split? What are the sides that got split? CD and DE and BH and HE. Over here on this side, HF is the side splitter to BG. So what got proportionally cut up? GF and FE and BH and HE. So CB and BG could be figured out and calculated later on once you proved that triangle BCE is similar to BGE. But in this case, we didn't have to prove that. We were just looking for this guy right here. Does that make sense, son? So that's why I had spent some time on the side splitter. Don't get confused with side splitter and trying to set up similar triangles. Again, side splitter split this guy proportional to this guy to this guy. This DH side splitter, this guy to this guy equals this guy to that guy. Does that make sense? Thank you, son. We're all good? All right, fantastic. Thank you very much, guys.